Hi, welcome to today's lesson on parallel and perpendicular lines. So let's start out with what do those mean? So what is parallel? Okay, so parallel has a visual meaning and it has a mathematical meaning. Okay, we use both of those. So let's talk about it. Okay. Parallel lines never touch. Okay. Now we're going to deal with very straight lines here. Not like if you go down the street, you'll see there's two yellow lines and they will sort of follow each other. They never touch. But we're not dealing with anything curves. We're going to deal with only straight lines. And parallel lines never touch each other. How do we know two lines are parallel? So if I have my little drawing here, bring up my little graph, my x and my y, and I have this line and I have this line. And maybe I drew them great, maybe not so great, but and I tell you they're parallel. Well, if I tell you they're parallel, then you have to believe me. But if I said, are they parallel? You'd say, well, how do you find out? How do you check? How do you not realize that maybe thousands of feet that way, these two lines are eventually going to come together and intersect and then go the other and then cross over? But it's such a small thing I can't visually tell. So how do I know if two lines are parallel? Okay, parallel lines have the exact same slope. So if I'm looking at an equation, so now I need the equation of these lines. If I have the equation of these lines, I can look at them and tell, hey, that line and that line have the same slope, therefore they're parallel. So if I said this equation was y equals 2x minus 2, and the one above it was y equals 2x plus, it looks like barely even, call it 0.5, I don't know. They have the same slope, they're parallel. There's no question, there's no wondering, there's no let's check it out. As soon as you see the equations in slope-intercept form, you just look at their slopes. Are they the same? Then they are parallel. Okay? Now, sometimes, and they love to ask these kinds of questions, they won't give you the equations in slope-intercept form. They'll give you maybe one in slope-intercept form. So maybe the first one looks like that, and the second one, looks like, I don't know, let's say 4x minus 2y equals 1. And you say, well, I don't know, are those parallel? How do I tell? One's in slope-intercept form, so I know the slope. The other one's not. It's in this form that I just learned called standard form. Well, now you understand another reason why I need to be able to rewrite the equation from standard form into slope-intercept form. So that's what I'm going to do. I would subtract the 4x from both sides. And then divide everything by negative 2. And I get y equals 2x minus 1/2. So that might not even represent this line because I got a negative 1/2 when I was thinking I should get a positive 1/2. So let me just change that to make that a minus. And now it is a plus. Now it is the equation that I wanted. So now you can see it. So that by changing the equation into slope-intercept form, I can tell if the slopes are the same. And that tells me whether the lines are parallel or not. Okay? So visually, you can eyeball it all you want, and you can say, well, they look like they're parallel. I don't think they intersect. But until you actually have their slopes in your hands, where you can say, the slope of this line is this, the slope of that line is that, and those are the same slope, you can't be sure if two lines are parallel. Now, if let's say I want to label these, I'm going to call this one A, I'm going to call this one B. How I would write this is I would say line A, and then it's weird. We actually it comes from these two things right here, are parallel to line B. If you have that information, that tells you that the slopes are the same. So again, if you aren't sure, look at what's given to you. Are the equations there? Are the slopes the same? Do they tell you if the lines are parallel? Because if you're just trying to do it visually, you're just never, you can't, what you can do then, the last thing you can do is you could count rise and run if they gave you some points that you could actually figure out. Like if I knew what this point was right here, and I knew this point, and I knew, even if I just knew this one and this one, if I could count the rise and the run for each of these two equations, that would give me the slope, and then I could tell if they're the same. Okay, that's all it is for parallel. Are the slopes the same? How you find the slopes? We can use the slope formula if they give us 2 points. We can count rise and run if they give us a graph. We can rewrite equations from standard form into slope-intercept form. Maybe one's in point slope and one's in slope-intercept. Doesn't matter. We're going to look at the slopes. Are the slopes the same? That's what tells us whether the lines are parallel. Okay? The other kind of special thing that we look at is something called perpendicular. Perpendicular. What does perpendicular means? Okay, perpendicular lines meet at a right angle. And if you remember, how do we indicate a right angle? So we have this line, and then we have that line. And if I've done it correctly, we get a little box. Okay, the little box. So this is 90 degrees. We indicate it with the little box. That tells me that the lines are perpendicular. But if that box wasn't there and I just had the equations of the two lines, how would I know if the lines are perpendicular? This is the trickiest part. Okay? So perpendicular lines slopes are, here we go, negative reciprocals of each other. For example, okay, 1/2 and negative 2/1. Now you might not see the over 1 part because they might not write it, so they might just say negative 2. So 1/2 and negative 2 are perpendicular slopes because they are negative, one's positive, one's negative, reciprocals of one another. So one's going to be positive, one's going to be negative, unless one's 0 and the other is undefined. That's the special case you kind of have to just know. Otherwise, you have this, the signs have to be opposites. One has to be positive, one has to be negative. It doesn't matter which one has to be the other. But then reciprocal means we flipped it. So we changed the sign and we flipped it. Okay? So I'm going to keep that, and I'm going to give you a couple of equations that would be perpendicular. So y equals 2x minus 1, and y equals negative 1/2 x plus 4. This part doesn't matter at all. All that we care about are these numbers right here. If they are negative reciprocals of one another, then you have perpendicular lines, meaning they would meet at a right angle. They would create a 90-degree angle where they intersect. In fact, they create 4 of them because they meet it like a T. Okay? So essentially, if you've got yourself a perfect T like this, and then you start rotating it, it doesn't change the T part of it, but the slopes stay in connection. Okay, positive, they are negative reciprocals of one another. Okay, so they flip and they change their sign. So the last thing I'm going to throw at you is this. They love to ask these kinds of questions. Okay, so here we go. I'm going to do two examples. Okay, they'll say write the equation of the line parallel to the given line passing through the given point. They love this. So here's your given equation, which is going to make my life really easy. Y equals 3x minus 1, and my given point will be 2, 4. Okay? Not trying to do anything clever, not trying to do anything tricky. So what am I going to do? All that I have to do. Well, I'm asked to write an equation, didn't tell me what form, so you know what form I'm always going to defer to? Point-slope form. Easiest one to get into. Because what? I've got a point. It's right here. Here's my x1 and my y1. And you know what? What's my slope? Well, if it's parallel, then it's the same slope. So I just grab the number, 3. Ta-da! So now I can write my equation. Y minus 4 equals 3 times x minus 2. And I'm done. I've written an equation in my case, point-slope form of a line parallel to this line passing through this point. Okay? So if I had to draw it, if I created a graph, they would line right up and you would look, you go, yep, those look like parallel lines. They look that way because they are. Okay? No matter how badly I draw them, they are because they have the same slope. Okay? The other thought they have is they might say, write the equation of the line perpendicular to the given line passing through the given point. So the only thing that would change here is instead of me, I'd still have my x1 and my y1. The only thing that would change is instead of me just grabbing the 3, I would grab the negative reciprocal of 3, which would be negative 1/3. So this 3 right here becomes negative 1/3. And now I have an equation written in point-slope form of a line passing through a given point that is perpendicular to the given line. So all you got to know is what's the relationship between their slopes. Parallel lines have the same slope. Perpendicular lines have the negative reciprocal slopes. So if you have an equation that doesn't have slope identified because it's not in point slope or slope intercept form, then you need to get it into preferably slope intercept form so you can identify the slope, so you can tell if the lines are parallel or if they're perpendicular. If you already have them, and if this were written in some other form and then they said they want it to be parallel or perpendicular, then I would have to convert it to find the slope so that I could just grab the slope and then either use the slope as it is or change it to its negative reciprocal for a perpendicular line. Okay, that is it for parallel and perpendicular, and I will see you in class.